which are very important, and which also makes it possible that the bootkit is able to support multiple operating systems, and it has these signatures to get executed and it stays undetected. And these signatures are similar for different systems, but have very often some slightly different. For example, 1 byte just different. So it's quite simple making it working on multiple systems. And here you see the signature for bypassing the code integrity verification of NT loader, which are just some bytes. But these bytes are assembly code instructions, so they are always working for multiple operating systems, because even if you recompile it or if you modify it, the code will reappear and will work again. And of course, there are some solutions to closed-source bootkits, and the most best one is the trusted platform module, which takes hashes of every boot file, including the BIOS and the master boot record and the bootloader and all boot files of Windows. And if you use that in connection with full volume encryption, then the trusted platform module will give only free the hash, will give only free the key if all hashes are valid and are the same as internally stored. So this means that you can only decrypt the drive if nothing was modified. And full volume encryption software could also secure its software. It could simply disable MBR override in Windows, which would make perfectly sense, because why should someone override the software? That would just make damage. And it could make some verifications if the MBR was modified and could restore it. And of course, you can make another dedicated attack against it and patch the verification, but it would close out all previous bootkits and would make it much more secure. And also the attacking vector should be considered, and not just as just encryption software, but also the security of it. And it should not just state that it requires physical security, because this is not always given. And bootkits might become also interesting for law enforcement agencies, because you can simply use it to install a Trojan on a fully encrypted computer, and the bootkit stays undetected and can't be detected if it's code written, and it has full access to the entire systems. And the only disadvantage is that this requires physical access, but which would be good for operative usage. So that someone, if you have a suspect that you are going to his computer, starting with a live CD and installing the Trojan, and then the Trojan is mailing you just everything data you want. And my Stone bootkit works for all systems and also for a full volume encryption system. And I've also included some features like boot applications and plugins, so it's easy to develop it further and integrate some other bootkit stuff. And the target is to own all Windows operating systems and to be able to patch the system and to bypass the code integrity verification to sign driver checks, and to create a quite sophisticated bootkit. And like the original Stone virus, my Stone bootkit is displaying at the startup your PC is now stoned again, and in a probability of 1 out of 8. The architecture is quite modified than other bootkits, and is quite new, because I'm not only using the master boot record, but also system files stored in the file system or to unpartition space. And I'm including my own FAT and NTFS file system drivers, so I don't need Windows to load my files. And this means I can just include much more code and, for example, payload drivers and everything, and Trojan or some other software, because I'm not only fixed to the 63 sectors. And I have decided to make it modularized, so it just consists of multiple modules and everything is independent from each other. And you can take a module and use it without the others, and makes it much easier to develop with, because you just have to recompile one module and not have to test and everything other. And as proof of concept, I've included in my Stone bootkit CMD extra privilege escalation, which is a normal driver written using the Windows driver kit, which just escalates the writes, the security writes of the CMD extra process to system from the normal user end. It should never happen that a normal user application gets system writes. And for this, I'm showing you now a demonstration with a new live CD. And this is based on Windows PE, and it infects now any drive, and will store the bootkit on the hard disk, which is fully encrypted with TrueCrypt. And then the bootkit becomes active, and you can see then that getting full access rights and can do everything at once. So what I'm going to do now is restarting my system. And using a live CD containing my infector. And this would be then really a practical usage, because someone would just need this live CD, or could also store it to a USB stick and simply execute it, and even if the hard disk is encrypted, he can store his own software. So I'm starting now from the CD, which is based on Windows PE. I've created it with the Windows Automated Installation Kit, a framework which you can use to create your own Windows PE image. And the Windows PE is just a more dynamic version of Windows, containing just the necessary files to load Windows. And it loads just a few files and is more fast, and has only the basic features implemented. And it does not contain any graphic user interface, not a shell or something, only it just executes my application. And this is the latest one. This is based on Windows 7. And here you see the software. It won't display any Explorer, and I have just to click this button. And it tries to write first the whole boot files on any drive that it finds, and then it tries to infect the physical drives. And here in this line, you see that the master boot record was successfully replaced. So my bootkit was installed, and I can now restart the computer. And there's the 1 in 8 probability that it shows up, your PC is now stoned. Okay, we won't get it to see. Now I still have to enter my password. Secure is secure. I think you wouldn't remember the password even if I tell you, so. And my bootkit becomes now active beside the Windows operating system, beside the kernel, and patches also some system files only in the memory. It does not modify anything on the hard disk, which makes it also much more difficult